Here's a video going over the problems that are on quiz 3 that you'll work on for Friday. In the first problem, we're simplifying a polynomial expression by combining like terms. In these problems in general, we have to look for possible places to use the distributive property to get rid of our parentheses. But in this case, the only operation that we have here is plus, and so we could just drop all the parentheses and that will mean the same thing. So I can look to collect like terms. So I'm going to look for my constant terms. There's a 7. That's a constant term, has no x's in it. And I look across and there's a 4. So 7 plus 4 is 11. Next is my x term. It's 5x. And there is no x term in the other part. So 5x is all I have. Next I have I don't seem to have a x squared term in the first part, but there is an x squared term in the second part, so it doesn't get combined with anything. There's not another one there. Then in the first part, I have an x cubed. I have minus 5x cubed in the first part, and I have minus 2x cubed in the second part. So minus 5x cubed minus 2x cubed is minus 7x cubed. And then finally, I have a minus 6x to the fourth, and there's no more x to the fourths there, so minus 6x to the fourth. So all I'm doing is combining terms of the same type, and I can do that with my constants and my cubic terms, my third degree terms, and the other ones are all just there by themselves, so they just get copied down. So that's what we're doing. In the second problem, we're just doing FOIL, so this is just practice. I can, you just do whatever you do. So most people write down, well, not most people. We can write down FOIL, the word FOIL, so F-O-I-L, if we wanted to use this tool. And so F means the first thing times the first thing. So the two first things multiply together. 5x times 3x would be 15x squared. So that would be my first term, or first times first. The second term would be the outer things multiplied together. And so that means these guys, we think of those as the outer terms. So that's a 5x times a negative 2. So 5x times negative 2 would be minus 10x. This next thing would be the inner. The I stands for inner. And so inner means the two numbers that are next to each other. Remember, we're always multiplying something from the first set of parentheses times something from the second set of parentheses. So plus 2 times 3x would be plus 6x. And then, last but not least, we have the last. By last, we mean the last two terms multiplied together. So these, the last numbers from each pair. So 2 times negative 2 is negative 4. So that is literally FOIL. That's the first, the outer, the inner, and the last. Like I said in class, what we're really doing there is looking at these two things and multiplying each of those two things by each of those two things in all possible ways. That's where you're getting the 4 terms from. But if they're mnemonic, F-O-I-L helps you remember that, then that's great. We'll just use that. Anyway, so when you do this, generally the first term is not going to combine with anything. The outer and inner are going to be able to be combined. I have minus 10x plus 6x, that's minus 4x. And then the last term there, minus 4, that's not going to be combined with anything. So the simplification is almost always just combining these two terms, the outer and the inner. All right, and the last problem is this vocabulary that I said in class and kind of pointed at things, but we didn't have too many notes on this. So you may have a question here. So in a polynomial, each of the individual terms, so each of these individual pieces are called monomials. So each are called monomials, where the mono there means like a single object, like one thing. And then polynomial means that you're adding or subtracting those monomials together. So each one of them will have a coefficient, and each one of them will have a degree. The constant term, the one that doesn't have an x in it, is kind of dumb. We just call it the constant term, really, because it's kind of weird to think of it any other way. But technically, that has degree 0. So we say that the constant term has degree 0. And if you're curious, not that it matters, if you can just remember that the constant term has degree 0, but it comes from the fact that when you raise something to the 0 power, we interpret that as 1. So an x to the 0 power really gets interpreted as no x is there at all. It's just a constant number. So that's why we think of that as degree 0. The other ones make a lot more sense. So the degree of this one is 7. The degree is the power that you see there, the exponent, and the coefficient. This question doesn't ask this, but I'm just going to say the words anyway. So the coefficient is minus 5. So the coefficient is the number in front, and the degree is the power up there. So the next one has degree 5, and in fact, coincidentally, the coefficient is also 5. Both the number in front and the power are 5. The last one has degree 8, and the coefficient is 3. So each individual term has a degree and a coefficient. And so it's nice because then we can talk about individual terms and we can communicate and know what each other's talking about. So I could write this polynomial down and say, hey, look at that coefficient on the degree 7 term. And you know which term I'm talking about, and you know what number I'm talking about. So once we put it together into a polynomial, then we have all of these guys added together. Then we interpret degree as being the highest power that we see among all the terms. So the highest power among the terms that we see in this case would be 8. So we would say this is an 8th degree polynomial because the highest degree that we see in any of the terms is 8. So it's not necessarily the first exponent that we see, the first power we see, it's just the highest power that we see. And just to complete the story with the terms, the coefficient, so when we talk about the lead, you'll see the phrase lead coefficient of the polynomial. So the word lead there sounds like it should be the first coefficient that you see, but it really means the coefficient on that highest degree term. So the lead coefficient of the polynomial is the coefficient that goes with the highest power. So in this case, that would be 3. 3 is the coefficient that goes with the x to the 8, and 8 is the highest among the powers that I see there. So the term that I circled there in blue, sometimes we call that the lead term in the polynomial. And the deceptive thing about it is that makes perfect sense if you always start with that one, but you can put them in any order you want. So even though it doesn't necessarily have to come at the beginning, we still call that the lead coefficient, meaning it is the sort of the one that has the most, is doing the most here. Well, and we'll talk more about that next week. But for right now, this is just vocabulary.